Well, welcome to our next lesson in solving quadratic equations, and this lesson is on completing the square. So our learning targets, we have two of them for this lesson. We're going to solve quadratic equations using the square root property and also by completing the square. And so far we learned how to solve quadratic equations by graphing and by factoring. And we're going to add one more method to that today, and that is through completing the square. And when we complete the square, this creates a perfect square trinomial, and we use what's called the square root property. So first of all, I want to start off with an example where you can actually solve this quadratic equation by using the square root property. What we have on both sides are perfect squares, and you may not recognize the one on the left. That one actually is a perfect square, and it factors as x plus 5, the quantity squared, because 25 is a perfect square. So we want factors of 25 that add to 10, which are 5 and 5. The signs are the same and they're both plus. So it's x plus 5 times x plus 5, and we can write that as x plus 5, the quantity squared. Well, now what we can do, since we have a perfect square on the left and a perfect square on the right, we can take the square root of both sides, and we're left with x plus 5 is equal to plus and minus the square root of 49. Now, remember when we're solving equations for x, when we take the square root of a number from now on, we're going to have to take both the positive and the negative values, okay, because we know that 49, if we take negative 7 squared, we get 49, or positive 7 squared is 49. So we're going to use both of those answers. Then we're going to subtract 5 from both sides. Oops, we took the square root there, so plus and minus 7. Subtract 5 from both sides, so we get x is equal to negative 5 plus and minus 7. And then you have to split them up. So you're going to have negative 5 plus 7 or negative 5 minus 7. That's what the plus and minus means. One of them is negative 5 plus 7, the other one's negative 5 minus 7. And now if we go ahead and simplify that, we get a positive 2 and a negative 12. So you can only use the square root property if you have a perfect square. So what happens if you have a trinomial that's not a perfect square? Well, that's where this completing the square process comes into play. It forces that trinomial into a perfect square. So here's the process for completing the square. So we're going to start out, our equation has to be in standard form here. And the first thing we're going to do is we're going to subtract the constant term or move it to the right. Then we're going to take half of the coefficient of the linear term, half of b, and we're going to square it. And so half of b squared we're going to add to both sides. So right in here we're going to drop this b over 2, the quantity squared, and we're going to add it to both sides of the equation so that we're not changing the value of the equation. Then this trinomial on the left is a perfect square. And it factors, you take the square root of this term and the square root of this term, which is b over 2, and you can write it in parentheses squared, and whatever sign is right here is the sign that's right here. If this were a minus right here, this would be a minus right here. And then the right-hand side, we simply get like denominators and combine those terms. There won't be any variables over there. There's just going to be constant terms. And then once we do that, we take the square root of both sides, and that's where we get plus and minus our answer. So that's the method, and that'll make a lot more sense after we do some examples. So let's take a baby step. The first thing I'm going to have you do is be able to find a value of a trinomial that will force it to be a perfect square. So in this example, b is 12, right? It's the coefficient in front of the linear term. So half of 12 is 6. And then we want to square that. 6 squared is 36. So this is the number we add to both sides. So then I'm going to come over here. So we're going to go x squared plus 12x plus 36. Okay, this is the value of c that makes this a perfect square trinomial. Because now we can write this as x plus 6, the quantity squared. Okay, so you need to be able to do that process with any trinomial. So here's one where we're going to go all the way through and actually complete the square and solve it. So first of all, we're going to take and we're going to move the 20 to the right, or add 20 to both sides. So we're going to get x squared plus 8x is equal to 20. And then half of 8 is 4, right? Half of our linear term. And we're going to square that and add it to both sides. Now on the left-hand side, I always leave it as the number squared because that tells me what goes in the factor, okay? On the right-hand side, I always square it and add it up. So I always take the number and square it, so that's a 16. Now this trinomial on the left is a perfect square. It's x plus 4, the quantity squared. On the right, we have a 36. Well, now you can see we have two perfect squares. And we can take the square root of both sides then, giving us x plus 4 is equal to, once you take the square root of the right-hand side, that's where the plus and minus comes into being. So it's plus and minus 6. So then we're going to split them, okay? We're going to say x is equal to negative 4 plus 6, and x is equal to negative 4 minus 6. I think I skipped a step down here. X equals negative 4, so we subtract 4 from both sides, plus and minus 6. And that's where you split those. And then just add these together. Negative 4 plus 6 is positive 2, and negative 4 minus 6 is negative 10. So those are our two solutions to the quadratic equation. What if the coefficient of the quadratic term is not 1? So far we've always had an x squared term whose coefficient is 1. If it isn't, our very first step has to be to divide each of the terms in the quadratic equation by whatever that coefficient is. So in this example, we will have to divide every term by 2. So when we do that, we get x squared minus 5 halves x plus 3 halves equals 0. The rest is exactly the same. We want to move the constant term to the right. Don't be afraid of the fractions. And then what we're going to do is take half of this linear term and square it. Well, what is half of 5 halves? And this might be helpful for me to write this out. So let me pick a different color here. Half of 5 halves. Hopefully you remember how to multiply your fractions, and that'll give us 5/4, right? So 5/4 is what we're going to square, and that's where the 25/16 comes from. So this one, I'll just write this out. This was equal to 5/4, and that's the thing we want to have squared. When we square this, 5 squared is 25, 4 squared is 16. That's the thing we add to both sides. Okay? Now at this point, when you've added that term to both sides, your left-hand side should be a perfect square. Take the square root of x squared, which is x, the square root of this one squared, which is 5/4. So we should have x minus 5/4. The quantity squared is equal to the right-hand side. You have to get a common denominator here. So you multiply by 8 over 8. Okay, and that term, if I multiply this times 8 and this one times 8, I get negative 24/8. So I have a negative 24, over 16. I said 8, but I meant 16. Plus 25 over 16 gives me a positive 1 over 16. So there's the preliminary work. And so now we have two perfect squares again. So we're going to take the square root of both sides. I'm going to move up here over on the right. When I take the square root of each of these sides, okay, take the square root of this one and the square root of this one. The square root of 1 is 1. The square root of 16 is 4. And we have plus and minus. Don't forget to do your plus and minus in here. So we have x minus 5/4 is equal to plus and minus 1/4. Now we need to add 5/4 to both sides. So we get x equals 5/4 plus and minus 1/4, and then here's where you split them. One of your solutions is 5/4 plus 1/4, the other one is 5/4 minus 1/4. Go ahead and follow that through. X equals 5 plus 1 is 6/4, which is the same as 3 over 2. 5 minus 1 is 4 over 4, which is 1. So here's another one we want to solve by completing the square. So first of all, we're going to move our 11 to the other side. So we get x squared plus 4x equals negative 11. Half of 4 is 2, and we're going to square that to give us a 4. And 4 is what we're going to add to both sides. Now we have a perfect square. We can write this as x plus 2, the quantity squared, is equal to negative 7. And don't forget to add that term to both sides. It's not just to the left side, it's both sides. Now we're going to take the square root of both sides, so we get x plus 2 is equal to plus and minus the square root of negative 7. Well, and this is why we did the section on complex numbers, because now we have a complex number that we have to deal with. So our next step is to say, well, x plus 2 is equal to plus and minus I square roots of 7. So we're going to take that negative out as an I, and the 7 is stuck there. And then we're going to subtract 2 from both sides. So x equals negative 2 plus and minus I square roots of 7. So now let's break up our two solutions. One solution is negative 2 plus I square roots of 7, and the other is negative 2 minus I square roots of 7. Here's a lesson check for you to try. There's a total of 6 problems involved in these 2 slides. Please make sure you try these on your own, and we'll talk about those when you get to class next time. See ya!